this assessment, we're asked how we can modify this reaction, this reversible reaction, to produce either the carboxylic acid or an ester. I'm doing part A and B. You're getting bonus coverage in this video. So on screen is shown the acid catalyzed hydrolysis of an ester. We haven't shown the acid, but if we wanted to do this, we could do acid catalysis. And the reaction is at equilibrium. If we want to go to the carboxylic acid, we're going to rely on Le Chatelier's principle. So if we increase the concentration of water, meaning we add more water to the reaction, that's going to cause the reaction to shift to the right based on Le Chatelier's principle. Build up the concentration of reactants and the reaction will go towards products. Alternatively, what we can do is we can decrease the concentration of the alcohol. So maybe we set up the reaction, decrease the concentration of the ethanol. That's also going to make the reaction go to the right. Set up the reaction such that we boil off the ethanol. Any ethanol that forms leaves the solution, maybe a distillation. That's going to pull the reaction to the right. So to make more carboxylic acid, we're increasing the concentration of water and decreasing the concentration or removing the ethanol as it forms. That should give us insight into how we would make the ester. We do the opposite. If we want the reaction to go to the left, we can somehow pull the water away. So if we remove water, remove a reactant, now the equilibrium will shift to the left. We could also add the ethanol. By adding more ethanol, we increase the concentration of the products on the product side, and that will drive the reaction back to the left. So for this reaction at equilibrium, where KEQ is pretty close to 1, we can use Le Chatelier's principle to drive the equilibrium in either direction.